Alright, welcome to Closer's Mathematics class. Don't forget to subscribe, like and share this video. Alright, if you are following my videos, you've noticed that we've been discussing on lines, gradient of lines and likes. So in this particular video also, we are going to be talking about parallel line and the perpendicular line. When a line is said to be parallel, a parallel lines are lines that do not meet. Parallel lines are lines that do not meet. So like this is a parallel line. Are you getting what I'm saying now? That is a parallel line. But what do we now call a perpendicular line? A perpendicular line is a line that forms an angle 90 degree. So if you look at this now, you can see that an angle 90 degree is formed here. Then that makes it a what? A perpendicular line. All right. So when line does not meet, it is what? Parallel. When they makes an angle 90 degree, then it is perpendicular. Now, what's another important you need to know about parallel lines? Parallel lines have angle 0 degree. Why? Because there is no angle formed. It is a straight line. No angle is formed. I get what I'm saying now. No angle is formed. That is why it is what? It is 0 degree. All right. So, but for perpendicular line, it makes an angle 90 degree. I've shown you that before. So something like this. When it is like this, you can see an angle 90 is formed, or you have it like this, an angle 90 is formed, or you have it like this too, an angle 90 is formed. So whenever you have angle 90s, then it is what? It is perpendicular. I get what I'm saying now. All right. So let's see example. No, okay, before that, the gradient of parallel lines are equal. The gradients of parallel lines are equal, but for perpendicular, the product of two perpendicular lines will give you -1. The product of two perpendicular lines should give you -1. All right. So that is another key thing you need to know under perpendicular lines. All right. So now let's see example about what this means. All right. So let's see, we have an example here. The example says, show that the line y equals to, you want to show that the line y equals to -3x plus 2 and the line y plus 3x equals to 2 are parallel. You want to show that these lines are parallel. Somebody say parallel. All right. So you want to show that they are parallel. How do you show that they are parallel? Very simple. You see, this is already a straight line. This is already what? A straight line. This is an equation of a line. Don't forget that I told you that your equation of a line should be in the form what? Mx plus what? Plus c. Where your m is the what? Is the gradient. Your c is the what? Is the intercept. Are you following now? All right. So from here, so our solution, all right, so let's divide this book now. So if you look at our solution here now, we have the first line. Let's call it y1, which is what? -3. We have -3x plus 2. Now from here, what is our gradient? Our gradient here, m is what? -3. Sorry about that. Our gradient is what? -3. Are you seeing that now? All right. So since our gradient is -3, why do I say it's -3? Remember this is of this form. Are you seeing that now? So we've gotten our gradient here. Now let's see our second one now. Our second one, which is what? y2 now. Our y2, they say y2 plus what? Plus 3x is equals to what now? Is equals to 2. How do I say? Oh, sorry, is equal to 7, not 2. Is equal to 7. So equal to 7. All right. So all I need to do is to make y the subject of formula. So that means I'll transfer this 3 to this side. Are you seeing that? So we have y2 equals to what? 7 minus what? 3x. If you rearrange it, that will give you what? y2 equals to what? -3x plus what? 7. You can see our m here too is what? -3. Are you seeing that now? So our m1 is minus 3, then our m2 that we got from our y2 is also what? Minus 3. Are you seeing that now? So because m1 is equal to what? M2. What does that mean? That means the lines are what? Are parallel. Are you following? That means the lines are what? Parallel. Are you following that now? So that is the answer for this question. All right. So now let's see another question. All right. So let's say we have they want to find if these lines are parallel. So we have the first one, x equals to 3y plus 5, and so we want to check if they are parallel or perpendicular, and y plus 3x is equals to 2. Yes, we want to show whether these ones are parallel or perpendicular. Don't forget for parallel m1 must be equal to m2. For perpendicular, the product of the gradient should give us -1. All right, so that's the key thing. So to our example here, all I need to do is to make y is the subject of formula. All right, so let's do it this way. So this part I want to make y subject of formula, and this part I will also make y subject of formula. So here we have x minus what? 5, because I'll bring this 5 to this side. Are you seeing that now? Equal to what? 3y. That means I can say 3y is equal to what? X minus what? 5. Then what will I do? I'll divide through by what? By 3, because 3 is disturbing my y. So divide by 3, divide by 3, divide by 3. Are you seeing that now? 3 cancel 3. That means y is equal to what? 1 over 3 minus what? 1 over 3x. 1 over 3x minus what? 5 over 3. So that means my m1 here is what? 1 over 3. Are you seeing that now? My m1 is 1 over 3. The coefficient of your x is what we call m1. All right, so you've gotten that here. Now let's come to this part now. Make concept of formula. This one is even easy. Just bring 3 to this side. So this will be what? Y equal to what? 2 minus what? 3x, and that give us what? Y equal to what? Minus 3x plus 2. Are you seeing that now? So our m2 here is what? Is minus 3. Are you seeing that now? So now let's check if m1 m2 will give us -1, because I already can see from here that they are not parallel because their gradients are different. So if their gradients are different, that already tell me that what? They are not parallel. So the next thing for me to do is to check if they are perpendicular. And how will I know if they are perpendicular? Very simple. So let's find the product of these two. If it gives me -1, then they are perpendicular. So what's our m1? So that's 1 over what? 1 over 3 multiplied by what? Our m2, which is what? -3. Are you seeing that now? You can see 3 cancel 3. 1 times -1, that will give us -1. So that means these twos are what? Are perpendicular. They are what? Perpendicular. All right, don't forget to subscribe, like, and share the video. For parallel, m1 must be equal to m2. For perpendicular, the product of your m1 and m2 should be equal to what? -1. All right, so let me give you assignment so that you can also practice and see what this looks like. All right, so number 1, check which of the following are parallel or perpendicular. So we have the first one, y equals to x plus 5, and y equal to minus x plus 5. Yes, check if this is perpendicular or parallel. Number 2, we have y equals to, we have 2y. We have 2y minus 6. 2y minus 6 equals to 5x, and so we have 2y minus 6 equals to 5x, and 3 minus 5y equals to 2x. So check which of the following is perpendicular. Let me add one more so that you can enjoy while you are solving. All right, so let's say we have y equals to 2x minus 1 and 2y, and 2y is equals to 2y minus 4x is equals to 8. Yes, so check which of them is parallel and which of them is perpendicular. Don't forget the theorem. For it to be parallel, m1 have to be equal to what? m2. For it to be perpendicular, the product of your gradients must be equal to what? -1. All right, so thank you very much for watching. Don't forget to subscribe, like and share this video. All right, see you in the next class. All right.